Testing for concavity. If the second derivative is greater than 0, i.e. it's positive, then f of x, the original function, is concave up. If the second derivative is less than 0, negative f of x is concave down. And if the second derivative equals 0, then it's neither concave up or concave down. It's basically a flat line. It's linear. Recording. Sweet. Okay, so how do we do concavity? So we need to do second derivatives, which are always a bit more work. So not the second. You don't. Critical values are for first derivative. We're going to call them. They're going to be called possible points of inflection. PPOIs is what we're going to call them. All right. So because this says the second derivative, you have to find the second derivative and set that equal to 0. Okay, not the first derivative. So. Oh, I see what you're saying. Oh, that's the second derivative test. Like, that's one step further. We're not there yet. Yeah. And that'll tell you if it's a max or a min. That bit, yeah. But we're going to look at the whole curvature of the graph. Yeah. Determine concavity for the graph. F of x is equal to x squared plus 1 over x squared minus 4. Okay. What's our first step? Take the derivative. I'll let you do that. It'll be good practice because you have to do this anyway. I'll freeze it and see if we all get the same. People have the first derivative yet? There's the first one. All right, now we got to find the second one. So take the derivative of that. All right. So what people got? Way down here. Something close to that. Okay, so 10 times 3x squared plus 4 over x squared minus 4. All right. So once you've got the second derivative, and you can see, look, it's a lot of work. What's going to happen on a test is I will give you the second derivative, okay? Because if you screw up the second derivative, like finding it, then the whole question's off, all right? So you have to know what to do with the second derivative now. So now that we have the second derivative, we take it and we ask ourselves, what makes it 0 or undefined, exactly like the critical numbers? 0 or undefined. So what makes it undefined? Undefined is when the bottom is 0. What makes the bottom 0? Here. Plus or minus 2, right? So, and we're going to call these possible points of inflection. And an inflection point is when the graph switches from concave down or concave up to concave down or concave down to concave up. It's when there's a switch, okay? So instead of writing out possible points of inflection every time, we're just going to say PPOI. Okay. So we know two of them are x is equal to plus or minus 2. Does anything make the top 0? You can try and solve it if you want. But if you tried to solve the top and went 3x squared plus 4 is equal to 0, you're going to get, and if you try to square root a negative number, it all blows up on you, okay? So nothing makes the top 0. So your only possible points of inflection are plus minus 2, okay? Those are the only ones. All right. So we do the exact same thing as what we did with first derivative. We put them on a number line. So we draw a number line. And I'm only focused on concavity right now. The next step is to put this all together. And then I always write the second derivative on the bottom. You do the exact same thing. You test the intervals to see if they're positive or negative. That's it. Okay? So any number that's less than negative 2. So negative 3. So let's look at the top first of all. Can the top, this, ever be negative? No, because you're squaring a number and then adding. So the top's always going to be positive. So then you just look at the bottom. -3 squared minus 9. Or -3 squared is 9. -3 squared minus 4. So 9 minus 4. Positive. Cubed, positive. Top is always positive. So what's a sign in this area? Positive. If you are if the second derivative is positive, you are, remember the original graph? Concave up. Okay. This is how I draw it. You can write concave up if you want. Concave up. And I'll show you what the graph looks like after this. Between -2 and +2, 0, and you're going to, if you put 0 in, you're going to get a negative number. So it's concave down. And then the next, put 3 in, it's going to be positive. It's going to be concave up. So you know the graph is concave up from -infinity to -2. Between -2 and 2, it's concave down, and from 2 on, it's concave up. This is what the graph looks like. And you can see from the original, we're going to talk about this. It's got asymptotes at ±2. So -2. So this is the graph. Now, what's important to notice is that just because the graph is concave up does not mean the graph is always going up, right? This graph is concave up, but it's actually going down, okay? And just because something is concave down does not mean that the graph is always going down. It means it can still be rising, but the curvature of it is facing down, okay? All right. Okay, let's summarize these things. Is everybody okay with that? Take the first derivative, set it equal to 0, you find your maxes and mins. Take the second derivative, set it equal to 0 or undefined, you find what are called the possible points of inflection. So since the concavity changes from here to here, we would say this is a point, a POI, a point of inflection. Okay, that's when concavity changes. Even though they're asymptotes, they're still POIs. All right, I want to summarize first and second derivative tests just so we have, you can put this on a separate piece of paper. This would be like your little summary of what we did yesterday and today. And there's a couple little things before we put this all together to actually start sketching graphs. So, first and second derivative test. So, first derivative. Critical points are when f prime of x equals 0 or undefined. If f prime of x is positive then graph is increasing, going up. If f, not f double prime, if f prime of x is negative, graph is decreasing, it's going down. If the derivative switches from positive to negative, so you've gone up and then down, you have a max at C, which is the critical number. And if f prime of x switches from negative to positive, this, you have a min at C, again, which is the critical number. That's first derivative, okay? Second derivative, do it in green. Talks about concavity. The PPOIs, the possible points of inflection, occur when f double prime of x equals 0 or undefined. So if the second derivative is positive, you're concave up. The graph has a curvature that's like that. If the second derivative is negative, you're concave down, which is like that. And then this is the side note that our Italian friends were talking about the last couple of days. The second derivative test is if you put the critical number, which is C, into the second derivative, and it is positive, then C is a minimum. So, because that would mean it's concave up, but C is our critical number. And the critical numbers, we know are maxes or mins. And if it's concave up, it has to be a minimum. All right? And if you put C into the second derivative and you get a negative number, then C is a max because it means the graph is curving down, and that's your C value sitting at the top. This is technically what the second derivative test is. It's useful for polynomials or when finding the second derivative is easy. Because as you can see in this question, even that's a fairly simple question, but the second derivative is a fair amount of work, okay? But if finding the second derivative is easy, this is a quicker way to do it. Good for polynomials. Okay. Now we need to start practicing this. Okay. So these questions are big. There's a lot of stuff in them. They're worth a lot of marks. They're probably like 8 to 10 mark questions. Okay. Just because there's so many steps involved. Does anybody have any questions about this right now? We're okay? All right. We're going to do a curve sketching question. Don't want to start it now. 7 minutes till break. It's going to take about 15 minutes. I don't really want it to stop in the middle of it. How about we just go for break now? Okay. And then when we come back, we will. You basically want to find your x and y intercepts. You want to find all asymptotes, vertical, horizontal, slant. We'll talk about what a slant asymptote is a bit later on. Critical numbers, PPOI, so that's where you're finding the first and second derivative, setting it equal to 0. Then we use our number line to determine the extrema, the max mins, or the concavity for the second derivative. Final step is to sketch the graph. Okay, so there's a lot involved here, and it can be super complex or it can be fairly straightforward. Polynomial functions tend to be the simplest. That's what we're going to start with, and then we're going to move into rational functions that have vertical, horizontal, slant asymptotes, all this kind of stuff. So once you get those down, we will practice doing a curve sketching problem. And we'll start with a polynomial. So when you're doing these problems, it helps, and most people in here are good, staying organized, all right? Because there's a lot of information at the end that you have to pull together. Do it in pencil, because you're probably going to erase things, especially when you're sketching the graph. If you want to see two people that don't know how to do this, just look out the door right now. Guy that's not wearing his mask. We got an anti-masker outside the door right now. Oh, sorry. Okay. All right. So we're sketching this polynomial. First step. Let's just find our x, y intercepts. There's no calculus involved in that. Okay. Does anybody remember how to find x, y intercepts? You just put in x is equal to 0, find the y-intercept, and y is equal to 0 to find the x-intercept. So x-intercept is y is equal to 0. 0 is equal to 3x to the 4. What do I do from there? Factor it and solve, basically. It's always factor. That's all we ever do in this class. So what are my x and y what are my x-intercepts? 0 for this one, and this is plus minus root 2. So For those of you that like decimals, root 2 is 1.41, a bunch of other stuff. All right. You got a mark. Congratulations. Did the X-intercepts. Maybe a half mark. So you get a half mark for X and Y. So let's do the Y. Y's are easy. Because the Y-intercept is when X is 0. If I put X equals 0 into that equation, what do I get? 0. Done. There you go. Now you got 1 mark. Congratulations. 1 out of, I don't know, 8, 10. We haven't done anything yet. So. All right. What's our next step? Asymptotes. Vertical asymptotes occur when what? There's a variable somewhere in the denominator because you're dividing by 0. We don't even have a denominator. In fact, this is a polynomial, right? Do polynomials have asymptotes of any kind? No, they don't. All right, so there's no vertical or horizontal. So you can even write that if you really want to. You don't have to. Asymptotes equals nope because it's a polynomial. All right, so we got no vertical or horizontal asymptotes. All right, so now we're on to the calculus. The critical numbers and the PPOIs, which requires us to do the derivative. So do first and second derivative, please. So there are your critical numbers and possible points of inflection. Square root of 1 over 3 is, for decimals, 0.57. Is everybody okay with where we got to right there? Everybody understands the derivatives, what I did to solve to get the critical numbers and PPOIs? Yep. Yeah, because it doesn't have a variable with it, right? I mean, you can divide it off, technically, and then it goes away, but yeah, because it doesn't have a variable, we don't really care about it. We're good? Okay. What's the next step? So now we do our number line, and we put in everything. So I'm going to do it in different colors. So I'll do the critical numbers in green. So 0, -1, positive 1, and that's for f prime of x. This is why I put f prime up top, and I'm going to do it in color-coded just so we can see it, what information it tells us. And I'll do the second derivative in red, the PPOIs. 1 over root 3, I guess, would be proper, and that's for the second derivative. Okay. So let's do the first derivative stuff first. So in green. Now, we only look at the green numbers. We don't look at the red numbers, right? So we're only doing first derivatives. So any number less than -1, let's say -2, we put it into the first derivative, right? That's what the green is for. If I put -2 into this equation, do I get a positive or a negative number? Negative number, right? Because -2 times 12 is, that's negative. -2 squared is positive, which is 4 minus that is positive. So I get a negative number. So the first derivative is negative here, which means the graph is going down. Now I pick any number between -1 and 0. All right, ignore the 0.57. This is for the second derivative. So in between the two greens, I can put 0.5. It doesn't matter. -0.5. -0.5 times 12 is negative. -0.5 squared minus 1 is negative. Negative times negative is positive. So that means on this interval, graph is going up. And then you do the same out here. So the next interval, I'll tell you, it's negative. And then it's positive. Mm-hmm. You can in this one.
No, I mean, if the first one is going down, and then you get to 0, then it must go up, and then no.
I'll show you one where it doesn't. It continues to go down. So it can be down, down. Like graphing. Yeah, I know I said that they don't always alternate, and then I give you every question that alternates, right? Yes. Yeah. All right, but they don't, and we're going to do one next where it doesn't alternate, okay? Polynomials tend to alternate, though. Nice simple polynomials like this tend to alternate. Anyway, okay, so where's our maxes and mins? We know what they are. That's a min, that's a max, and that's a min. Okay, so we've got those in our head. Boom. Now we gotta do second derivative test. Okay, or second derivative stuff. So in the red. Now we're only looking at the red. So this is my dividing line for my interval. I need a number that's less than -0.57. What would be a nice easy one? -1. They go into the second derivative, which is this guy. This guy. Okay? So I put -1 in here. Do I get a positive or negative number? Positive, right? So that means it's concave up on that interval. So it's positive on that interval. Then I'd have to pick between the two reds. What would be a nice easy number? 0, which gives me negative. So we're concave down. That's it. And then do it again. And it alternates, even though I say not everything alternates, but. Okay. Now we can sketch the graph. So we have to get all our info here. I'm going to sketch it over to the side here. Okay. So mark out your x and y intercepts. Our x-intercepts are 0 plus minus root 2 or 1.41. So 0 plus minus root 2. Our y-intercept is 0. We've already got that marked. There's no vertical or horizontal asymptotes. Next thing is to mark out your critical numbers. Okay? Our critical numbers were 0 and plus minus 1. 0 is already marked. Plus minus 1, so there's minus 1, plus 1. PPOIs are next. Plus minus 1/3, root 1/3, which is about 0.57, so they're sitting in here somewhere. And okay, we're ready to sketch. All right. So we use the table, the little this thing here. So I'm just gonna make sure I mark. We have to go through these points because these are our x-intercepts. Okay, so from negative, way out here, negative infinity to negative 1, the graph is going down and is concave up. Okay, and we have to go through that point there. So we're going down and concave up all the way to negative 1. Because at negative 1, we know we have a minimum, right? There's a minimum here. So we come down. This is where practice helps. We're coming down. We're concave up. We're still decreasing. And then at negative 1, we have a min. Because what happens at negative 1? The graph switches to increasing. And it increases from negative 1 to 0. And it's concave up all the way to 0.57. And then it switches concavity to being concave down. So this is where the practice helps. So I'll zoom in here. So it still starts to go up. When it gets to this 1/3, and now you can just erase and kind of figure it out after. It switches to being concave down. Now I'm going to exaggerate it. All right, that looks like an exaggeration. But you can see it's concave up, and then it switches. It's still increasing, but it's concave down. The graph is facing down now. At 0, it starts to decrease, but it's still concave down all the way to this 1 over root 3. So concave down. And then at there, it switches to concave up. Whoa, it's a bad drawing. And then at 1, we have a min again, and it starts to increase, and it's concave up all the way, and it has to go through root 2. And that's your graph. Now, if you really want me to make sure that I know you know where the concavity, the points of inflection are and stuff like that, you can simply write on the graph right here and say a POI. Okay, just so that I know that you know the concavity switch, because sometimes it can be hard to sketch that in. that okay? All right. Let's do one that's a little wrinkle in it. So we're all good? We're all good? No questions? If I was marking this, I would be 1 mark for the graph. Galaxy. So you get 1 mark for the graph. I'd give you 1 mark, maybe 2 marks for the table. Let's say 2 marks for the table, like, or this thing. I give you a mark for the first derivative, mark for the second derivative, mark for those, and if there's asymptotes, I'm going to give you a mark there. So 2, 3, 4, 5, 6. I'd probably give you some more marks for just finding the critical numbers in the PPOIs. So now you're looking at 8 marks. So they're going to be 8 to 10 mark questions, because if I throw in asymptotes, then that's a couple more marks and stuff, okay? So they're 8 to 10 mark questions. Pretty much every step is a mark, okay? All right, so let's do one that is not just alternates all the time. So here we go. We're going to sketch f of x is equal to 12 over 5 x to the 5th minus 4x cubed plus 1. I will tell you the x-intercepts, because to find them is going to be a little ugly. So the x-intercepts are negative 1.35, 0.71, and 1.19. So I've given you the x-intercepts. So that's going to require you to factor a 5th degree polynomial, which I'm making the assumption most people don't know how to do. All right. What do we do? So I've given you the x. We can find the y-intercept, which is what? 1, because you put x is equal to 0, so you get 1. So you get y is equal to 1. There you go. 1 mark. Congratulations. All right. Next step. Sorry? It's polynomial, so no asymptotes. All right. So now we're on to the calculus. Yep. So derive it first and second, please. And I'll freeze this and do it. And we'll see if we all get the same number. There's your derivatives.